that involves everything that we have done from video 1 up until video number 5. So it's more activities right now. Okay, the first one would be to look at such a triangle. Remember, at this stage we are dealing with right angle triangles. Right? We have this triangle, but the thing about this triangle is it is flipped over just like that. Alright, so don't always expect the usual oriented triangle. Things could just be flipped whichever way. But the good thing is this: in this triangle you will be given that is 90 degrees. Alright, so I have my angle there is Q, and I have R, and I have P, and then here I have 42 degrees, and I have my PR as 3. Calculate the length. Alright, so the first question is calculate the length of PQ in triangle PQR. Alright, that's my question there. Now, if I want the length of PQ, so this is what I want. Whenever you have a right angle triangle, alright, and this we need to start thinking of from grade 10. Whenever you have a right angle triangle, you need to think of two things only. You need to think of your SOHCAHTOA, and you need to think of your theorem of Pythagoras. These are the two things you need to think about consistently. So 90 degrees, think about this. Alright, now I have this to find. Okay, my Pythagoras would not work because I've got two unknowns. But let's see something. I have this angle here. The side facing the angle is called the opposite. That's my opposite side. It's opposite the angle. The side facing the angle 90 is my hypotenuse. And the third side adjacent to that angle is the adjacent side. We did this in video number 1. So if you look at what I have missing is the adjacent side. What I have given is the hypotenuse. This looks like somewhere SOHCAHTOA, which means I can then use cos. Okay, so let's see. Cos 42, let's clean that. Cos of 42 degrees, or let's start by saying, so that it becomes easier for us. Let's start by saying cos theta, we write the ratio. Adjacent over hypotenuse. Now what's my angle? 42 degrees. What is my adjacent? PQ. And what is the hypotenuse? 3 over 1. What do? We simply cross multiply. Alright, so PQ will be 3 cos 42 degrees. And what will your answer be? Here is not a special angle, so we run to our calculator. 2,23. Alright, 2,23. Depending on the instruction, how many decimal places? 2,23 units. And we're done with that question. Let's go for another one. Alright, I have a triangle here, and I'm going to ask you to try this quickly. Okay, this triangle is also flipped. It's actually flipped around this way. But it doesn't matter how, in which way it's flipped. What matters is for us to be able to identify the sides. I have a C there. I have A here. I have 5,6 and I have 67 degrees. The question wants us to calculate, there are 3 questions here. Calculate the length of AB. So number 1, calculate the length of AB. Number 2, calculate the length of BC. And number 3, what is the size of angle A? Okay, now if we look at the angle we are given, that's where you start from. The side becomes your opposite. Opposite this one becomes my hypotenuse. And then you have that. So let's check. AB. Do you notice that AB is opposite? And what other side do we have? We have our hypotenuse, which is what? 5, what? 6. And that's our AC. So if I have opposite and hypotenuse, what trig ratio am I using? Sine. So can I then say sine C, which what is my opposite? AB. And what's my hypotenuse? AC. Let's use the letters given. Alright, so what do we have? Sine 67. What is my AB? That's what I'm looking for. What about my AC? 5,6. Let's cross multiply. AB is 5,6 sine 67. Okay? 5,6 sine 67. 5,15. Alright, and since they used 1 decimal place, we can also just follow through. 5.2. So AB equals to 5,2 units. Alright, that's done there. Let's look at the next one. The length of BC. Since I have the 2 sides now, I can actually use my Pythagoras theorem. That's one option. But I can still continue with my trig ratio. Just to set an expectation quickly. What should I be expecting? Alright, I'm just going to do something here quickly. Use my Pythagoras on my calculator. 5,6 squared minus 5,2 squared. And by the way, I should be looking for the square root. I just want to have an expectation of my answer. My answer should be around 2,0. Alright, now, in looking for BC, what do we have? Let's create space on the side of the board. What do we have? Oh no, we got that. We're looking for the size of BC. Okay, if you notice, we have BC is actually our adjacent side. Alright, so BC is our adjacent side. By the way, we do have our opposite side, which is AB. Also, we have the opposite side, AB. And if you look at this OR, we can look at tan, because it's opposite of our adjacent. So, can I then say tan C, alright, is opposite AB over adjacent BC. Now, if we substitute tan 67, what is my AB? 5,2 over what? BC. If we cross multiply, because it's over 1, remember? If we cross multiply, we would have BC tan 67 equals to 5,2. Divide both sides by tan. What do we have? 5,2 over tan 67. Remember, we did a few algebra representation of trigonometry. So what we have here is 5,2 divided by 1067. Alright, our answer is 2,2. Lovely. Answer is 2,2. So BC is 2,2 units. Somebody else is thinking, is that the only way? Because somebody else is thinking, I've got another idea. Can I use something else? Let's try. Let's see. It's mathematics. There's more. We actually have more than one option. Remember here, if I go back to my diagram, I also have my hypotenuse, and I'm looking for my adjacent. Alright? Hypotenuse and adjacent. What do you see there? That's cos. So cos, what angle are we dealing with? C. Alright. Cos C. Which side is my adjacent? BC. See, it's good to label. Alright. BC over AC. So cos 67. Remember, I'm looking for BC. And our AC is given as 5,6. Can we cross multiply? BC therefore is 5,6 cos 67. Okay. 2, round it up again, 2,2. Alright. So 2,2 units. So whichever way, even the Pythagoras got us about 2,2 rounded off as well. Okay, so this is 2,2. The next question says, find the size of A. Find the size of A. I want to keep this triangle very close to me. I'm sure you've written all of this down. The size of A. So we're looking for angle A. Oh, it's so easy. But I'm going to try to do it in so many ways. This whole triangle is just 180. So remember that this is 90. So I could just simply say angle A plus angle C should give me 90 degrees. Alright, so angle A will simply be 90 minus 67, and that will be equal to 23 degrees. But let's try something else. I want us to find the angle using trig ratios. Using trig ratios. So we are expecting to get a 23. Let me just put it here. We are expecting to get a 23. Alright. Let's go look at our sides. My adjacent side, which is BC, is 2,2. Alright. Now that was the information given earlier on. But let's focus on angle A. So I won't call this my adjacent side. To make it a bit neater, I am going to use a green marker now just to create a difference. My focus is on this angle. Please watch this. Since I'm focusing on this angle, my opposite side is now that opposite to the angle I am focusing on, right? Good. My hypotenuse remains the same. I'm using the green note, and this side becomes my what? Adjacent. So I'm going to put that down. BC is 2,2, and that side is my opposite side. I hope it makes sense, because I'm looking at angle A. That's my focus. AB is 5,2, and that is my adjacent side. And AC remains my hypotenuse. Alright. So all of these reference to angle what? A. If I'm looking at A, these are the three sides that I have. Since I have my three sides, I can actually use any trig ratio. Sine A is opposite over hypotenuse. So sine A What is my opposite? BC. And my hypotenuse? AC. Okay. And what is sine A? What is BC? 2,2. What is my hypotenuse? 5,6. We're doing this so that we know how to get our ratios, our angles. Okay. So I do have this 2,2 divided by 5,6. Okay. I'm going to teach you how to avoid making mistakes and rounding off during a calculation. So let's use a fraction, 11/28. Or rather, from here, let me show you a very more standard skill. I won't even use my calculator for now. What is A? A is going to be the sign, remember, of this whole thing. This is actually nicer. It gives you a more accurate value. Alright, gives you, so you don't have to do any form of rounding off. Alright, I'm sure you remember how to get the shift sign there. And then you put the whole thing in bracket, 2,2 over 5,6. The more you round off, the more you move away from your answer. And that's our answer there, 23,1, which is absolutely very close to 23 that we got. So A is 23,1 degrees. Beautiful. Beautiful. So go through again, looking at angle A, which one is the opposite, which one is the adjacent, and which one is the hypotenuse. Then you can use any of the trig ratios. Let's try to use cos. Alright, what will my cos A be? Remember what cos is? What is your cosine trig ratio? Cos A, what is cos? Is adjacent over what? Hypotenuse. So, cos A, what is my adjacent side to A? Let's go check. Adjacent is AB, and my hypotenuse is still what? AC. So it's basically AB over AC. So can we then say cos A, okay, what is my AB? Measurement of AB, 5,2 over 5,6. I'm sure you remember where these values are popping out from. What's the easier way here? A equals to what? Shift cos 5,2 over 5,6. Alright. Shift cos 5,2 over 5,6. Alright, we have 21,78, which is about 22. Alright, the divisions are coming from the fact that we've been rounding off all along. So we have 21,78. So basically 22 degrees, which is still going to be accepted because it's very close to 23. Remember, all kinds of rounding off has been done. Alright, let's look at one more question in this video, and the next video we will then do with exam papers now on our trig functions. Okay, we have such question here. It's a very complex diagram, so it's going to take me some time to get done with this. Alright, I'm just going to pause and draw. We'll be back when the diagram is done. Alright, there we go. That is the diagram. And the question says, calculate the length of BC. Let's see. We are told to calculate the length of BC. What is it that we are going to work with? Alright, let's go to the diagram. BC. question mark, unknown. For me to work with my trig ratio, remember at least I must have either two sides, or I must have one side and one angle. That's how it works. But if you look at BC here, I do not have anything except for this angle. Alright, I'm going to take you step by step, calculate the length of BC. Let's check something here. If you look at BC, where is BC? BC is actually right here in this triangle. Now, I have this angle 20. It means this side is my what? Opposite. The side facing angle 90 is my hypotenuse. Alright, let's check something here. If I were to write down sine 20, it will be BC opposite. Okay, let's first write the whole sine A. Can I say sine A will be equal to opposite BC, which is opposite, over hypotenuse? Let's start from there. Therefore, sine 20 over AC. I do have a problem. I do not have AC. Okay, that gives me a very, very big challenge. Let's see. If I can get AC, then I'll be able to get BC. Let's go study AC quickly. Oh, by the way, do you notice that AC is also an hypotenuse to a blue shaded triangle now? And with this blue shaded triangle, I've got a problem as well. I only have one side. I only have one angle. My AC is still missing. By the way, there's a third triangle. Hold on. Let's green up this triangle. In this triangle, I actually have two things. Oh, by the way, don't forget that angle on a straight line is 90. So if this is 90, this is also 90 degrees. That's what the examiner is trying to hide from us. Ah, okay, makes sense now. So if I have, let's focus on the green triangle now. So it's a lot of analysis that's going on here. If I have this triangle, watch this, I can calculate AD. If I get AD, I am now on the blue side. Alright, I can calculate this, H. And if I get H, I can get my sine. Oh, it's a multi-step question, which means we've got to analyze the triangles first. Alright, let's go again. See, my problem is I got stuck here looking for AC. But AC is connected to the blue triangle, ADC, which is also giving me a problem. But ADC, the blue triangle, has AD, can you see AD as a common line connected to the third triangle, where I have actually one side and one angle. So let's go to the green triangle quickly. So I'm going to the green triangle. What am I looking for? In the green triangle, I am going to calculate side AD. Okay, let me use a black ink this time around. Now look at the angle I have, 14. This side becomes my opposite. Remember, the side facing angle 90 becomes my hypotenuse, and AD becomes my what? Adjacent. What am I looking for? Adjacent. What do I have? Hypotenuse. Alright. AD is adjacent. AE is hypotenuse. What trig ratio do you see there? Car, which is what? Cos. So can we say cos A equals to, what's my cos? Adjacent over what? Hypotenuse. What is the value of cos A? 14. What is my A? It's AD. And what's the hypotenuse? 70. Can we just cross multiply what we have? AD equals to 70 cos 14. Now what's my answer going to be? 70 cos 14. Alright, we have 67.92 millimeters. That's my step number 1. I have my AD. Now, since I have AD is part of the blue triangle, which can then assist me in calculating AC. Alright, I hope you've taken that step down, because I want to create space without moving this image. You can pause the video and quickly take that note down. Okay, so I have my AD. I'm just going to put my value here, 67, what? 92. Okay, now let's use the blue triangle. What do I know? I have an angle in the blue triangle, and my angle is 36, right? The side, I'm using blue now. Let me clean so that we have, since we're done with this triangle, I'm just going to walk around the triangle that I have values on. Since I'm done with this triangle, let's just clean it for clarity. Okay, so what is my AD? Remember, we said our AD is what? 67,92. Alright, since we know we are focusing on the blue triangle. The angle there in the blue triangle, we have 36 degrees. Now, looking at that angle, that is opposite. Angle 90, that is hypotenuse. Automatically, this side is adjacent. If I can get AC, remember AC is connected to the triangle I'm actually looking for at the end of the day. So, I have AD as my adjacent side, and I have AC as my hypotenuse. Again, what do you see? I see car there, which is what? Cos. Alright, since I have that, can we then work through? Cos A adjacent, which is what? AD. Let's start by saying adjacent over what? Hypotenuse. Cos A, what's my adjacent? AD. And what's my hypotenuse? AC. So can I say cos 36, what is my AD? 67,92. And I have my AC. Alright, mathematics, what do? Cross multiply. AC cos 36 equals to 67,92. What is AC therefore? 67,92 over cos 36. Alright, so what is AC? 67,92. Alright, 67,92 divided by cos 36. Okay, we have a very long side there, 149,6. 149,6. Don't be afraid of very big answers. Okay, millimeters. So we have our AC given 149,6 millimeters. Alright, now we're back to where we started from. Remember we said now this is opposite and this is hypotenuse, sine. So can I then say sine 20, we already had this formula, BC over what? AC. Sine 20 equals to BC over, and what our AC? 149,6. So what is BC? 149,6 sine what? 20. And what is your final answer going to be? Alright. Okay, I'm just going to use this and say sine 20. Remember, I'm using the previous answer without running off. 51,16. Alright, 51.16. And that's our answer there. Quite lovely example here. So we see the multi-steps. You've got to keep working it out, raising it out before you get to your final answer. Alright, we've clocked to the 30 minutes mark in this lesson. Good luck. We will then look at our next session will be more activities, but right now we're going to deal with an exam type of paper. Catch you in the next class. Goodbye.